Today we study the calculus. The topic is the area of some plane region. So now look at the question. Try to find the area of the curved trapezoid if the region A is bounded by y equals fx is positive. Corresponding x equals A, x equals B, and y equals 0. Sometimes y equals 0 right at and x-axis. Try to find the area of A. Look at the figure. Its area is given by the corresponding figure. It is our curved trapezoid. Y equals fx, x equals A, x equals B, and y equals 0 means x-axis. How to find the area of the region? The area of the region equals some definite from A to B, fx dx. Our idea means try to use the definite integral. How to understand the idea? The idea means look at the figure. Try to find the area of the region. We have known the basic area of some rectangular. So taking the point x and do the x the line, another point x plus dx, we can get some special rectangle. From the rectangle, we know the area, the element dA equals bottom time corresponding height. What is our bottom? The point is x. The point is x plus dx. The subtraction equals dx. It is our bottom. How about the height? The point is x. Corresponding height is fx. For example, if x equals 2, the height equals f2. X equals 5, the height equals f5. f5 is value. So corresponding the area element of the rectangle equals bottom times the height, fx dx. It is called as corresponding element area, means differentiable A equals fx dx. Our element, how to get all the total area? Using the definite integral means the area of the given region from integral A to B. From A to B, we have known it is some definite integral. In fact, it is a value. The value may be positive number, may be negative number. So now, in this question, I have studied fx is a positive line. How to understand the corresponding geometric meaning? So now look at corresponding geometrical meaning. There are two cases. If fx is positive, means less than 0. Corresponding the definite value is a positive number. It is our area. This means the area of the curved trapezoid is our funded. Another case, fx is negative. Fx is negative. The definite integral from A to B, maybe it is a minus number, means negative number. For example, minus 5. Minus 5, not a positive number. The area is measured by some positive number. So we can take minus A. This is a negative number. A is positive. Consider the minus means minus, they are negative. So corresponding geometrical meaning means negative value of the area of the corresponding the curved trapezoid. Now look at concrete figure. If fx is giving sometimes positive number, sometimes negative number, we can get the three areas. The first part is A1, the second part is A2, third part is A3. A1, A2, A3 are areas, so corresponding the values must be positive. How to compute corresponding definite integral? Look at this. AB fx dx. Consider the geometrical meaning. Consider the two formulas. If fx is a positive number equals itself, means the area itself. Another case, fx less than 0. At this time, corresponding the definite integral equals minus a. So we have the following result. A1 equals positive A1. A3 equals positive A3. Look at, pay attention to A2. Corresponding fx less than 0. So this time equals minus A2. Together, the final value, it is our definite integral. So now, how to compute the region area? There are two cases. Case 1. Consider the more complex cases. If fx larger than or equal to gx, try to find the area of A bounded by the corresponding curves y equals fx, y equals gx, and the two lines x equals A, x equals B. Look at corresponding the figure. The area between y equals fx, the upper curve, corresponding the lower curve, y equals gx, the curved trapezoid, x equals A and x equals B. How to compute the area of the region? So now look at using the element idea. Giving A, taking the point x. Another point is x plus dx. How to compute the area element? Corresponding, there are three steps. Step 1, taking the interval x plus dx on the given domain. On the given domain, taking some consider little interval. So now look at the area of the rectangular. The means corresponding area element dA. dA means areas of some rectangular equals the bottom times the height. Bottom equals dx. How about the height? The height equals fx gx. The distance, the height equals fx minus gx. So this term. How about this term? Positive or negative? Okay, the given condition, fx is larger than or equal to gx. So equals f minus g. So you don't care if it is negative because this term is positive. It is our area element. The step 3, we try to denote dA as our final area. So do the definite integral. A integral itself. Integral the same term from given variable A to B. Pay attention to the 3 steps. You try to understand, okay? Taking the interval, try to get area element, and then get the final area. Pay attention to the integral variable x. How to remember? Pay attention to s between A and B means in this interval, in this domain. So now we can consider case 2. Why case 2? Maybe variable is y. Now look at case 2. If fy larger than or equal to gy, try to find the area of A bounded by the curves x equals fy, x equals gy, and the two lines y equals c and y equals d. Look at corresponding figure. Y equals c and y equals d. Look at this curve is x equals fy. Another curve is x equals gy. Y from C to D. How to get the element area? So step 1, taking the interval y to y plus dy on the given domain CD. From y plus dy, consider the little area, means area element. So we can get corresponding dA in the similar meaning in case 1. the area of rectangular equals the bottom means fy minus gy, corresponding to height. At this time, the height means dy. So we can get height times the bottom means the area of some rectangular. The last step, we denote dA as our final area. Y is our integral variable. Y changeable in the interval. So y from C to D. This is our final formula for the area region. How to compute? Remember, if y is our integral variable, try to become the integral function is a function for the same variable y. So y from C to D. So now look at example 1. Try to find the corresponding definite integral. How to do? Okay, we have studied the geometrical meaning. By geometrical meaning, we can get corresponding y equals square root 1 minus x squared. Maybe this part between x equals 0, x equals 1, and x-axis. How to get? Because the geometrical meaning means the definite corresponding integral equals the area of the given region. How about the given region? The given region area. This means pi r squared over 4. In this question, the radius is 1, so equals pi times 1 squared over 4. Final result equals pi over 4. This question is solved by our geometrical meaning. Now look at example 2. Try to find the area bounded by x minus y equals 0 and y equals x squared minus 2x. How to understand? The first question, some region is bounded by 2 curves and 2 lines. But in this question, the area bounded by 2 curves. Okay, now we try to draw the figure and look at what kind of region. So now, drawing corresponding the figure. This is our y equals x squared minus double x. So this is our one curve. Drawing another line, x minus y equals 0 means corresponding the right line together bounded by means bounded. So corresponding this part, this is our region. How to find the area of the region? How to find it? Okay, so now we try to find corresponding the intersection points. Look at, if it is our x, this point is our x plus dx. We can get corresponding the area argument. Through the part, get all the area of the region. The first step is to know x equals a and x equals b. How about b? B means the intersection point. So the first step, from the right figure, we can obtain the corresponding intersection point. These 2 curves become one system. For x and y, we can get there are 2 intersection points. One is 0, 0, means our original point. Another point is 3, 3, means this intersection point. From the 2 intersection points, we can know corresponding the domain for x. So now there are 2 ideas. Maybe you can think x is our integral variable. Okay, so now in the method 1, if x is our integral variable, at this time x belongs to 0 and 3. dA means corresponding the area element equals x minus this part. How to get? X is our integral variable. If x is given, corresponding y equals x. X is giving corresponding y equals x squared minus double x. How to get corresponding the height? Upper point minus lower point, okay? Upper point y equals x means fx. Lower point means y equals gx. X squared minus double x. This is our the corresponding height. Bracket times the bottom, okay? This is our area element. So we can get the final area equals definite integral x between 0 and 3. So becomes 0 to 3. Now it is very easy. For only one variable means definite integral for the polynomials. Final result equals 9/2. This question we have studied, okay? For the x is our integral variable. How about variable y? So now look at method 2. Y is our integral variable. So we can study what values are our c and d. This point equals -1. This intersection point corresponding d equals 3. So now look at. If this is our A1, this is our A2, all the area A equals A1 plus A2. How to compute A1 and A2? Look at A1. A1 means one y is giving compute corresponding. A2, how to compute the area of the pink rectangle. So now look at the idea. A1, A2. If y is integral variable, write corresponding domain. Y between is -1 to 3. dA1, look at A1, okay? A1 from -1 to 0. So A1 we can get the first x minus another x bracket times dy. Because y is our integral variable, you cannot write dx. You must write dy. Y is our function variable. How to compute? Look at the corresponding figure. Y equals x squared minus double x. So x equals 1 minus or plus square root y plus 1. Look at the figure. Right point y equals 1 plus square root y plus 1. The left point equals 1 minus square root 1 plus 1. So corresponding, this is our bottom times the height. dA1 is obtained. How about dA2? In the similar meaning, pay attention to y still our integral variable. How about corresponding the bottom? Right point minus left point. Right point in this curve. Left point in this equation. So we can get the right point. How about x? Yes, the x equals 1 plus square root y plus 1. The right point equals y. This x equals y bracket times dy. Y is our integral variable. Pay attention to dA1 and dA2. Write this formula. Only consider y. Doesn't say anything about x. Okay. So now a equals a1 plus a2. A1 together equals y from -1 to 0. Look at the figure. From -1 to 0. Okay. Plus a2. A2, copy this term. A2, y from 0 to 3. Y from 0 to 3. So now we can get the corresponding definite final result 9/2. Compare the two values in method 2 and another method 1. They are equal. But in this question, method 1 is more easier than method 2. If you do the question, it is decided by yourself, okay? So now, we look at example 3. Try to find the area of the region between the parabola y squared equals 4x and the line 4x minus 3y equals 4. The similar question as example 2, corresponding the region is bounded by some curve and some line. The first step, you should try to find the intersection point. Y squared equals 4x, and the line 4x minus 3y equals 4. We can get corresponding intersection points. There are 2. This is one intersection point. This is another intersection point. From the intersection points, we can try to make up which variable is our corresponding integral variable and corresponding domain. So now we can get the area of the given region equals y is our integral variable. How about y? Look at the corresponding points. Y equals minus 1 and y equals 4. So y from C to 4. Y, the bracket means x equals what expression minus another expression from here. X equals 4 plus 3y over 4. So the first term, another given equation. X equals y squared over 4. So y squared over 4 bracket dy. So y is our integral variable. We can get minus 1 to 4. The final definite result equals 125 over 24. We have studied the 3 examples, so now try to remember corresponding our formula. The formula 1, the area equals some definite integral value. Pay attention to the geometry meaning. Maybe corresponding definite integral sometimes positive, sometimes negative. There are 2 cases for the different integral variables. X between A and B at this time, corresponding area equals this expression x from A to B. Pay attention to x is our integral variable. This is related. y2 minus y1 means upper point minus lower point. X, okay? Pay attention to the same variable as between A and B. In the similar meaning, if y is our integral variable, we can get this formula, y from C to D. There are 3 steps. The concrete step. Step 1, how to do? Okay, try to find some intersection point. Sometimes corresponding AB or CD are not given directly. You should try to get corresponding AB, CD by the intersection points. Step 2, try to draw corresponding the figure. From the figure, we can make sure maybe x is our integral variable, maybe y is our integral variable. Finally step, find the area by concrete computation, means by computing concrete definite integral. According to the basic knowledge, try to understand. We will finish the following 2 questions. Look at question 1. Find the area A bounded by y equals x cubed minus 3x squared minus x plus 3 and x-axis and the 2 lines x equals minus 1 and x equals 2. It is our special curved trapezoid. So now look at corresponding the figure. Y equals this expression. Sometimes it is positive number, sometimes it is negative number. So there are some part like this, another part like this. Try to find the area. Pay attention to. We can find the corresponding intersection point. X values equals minus 1 and positive 1. The area of region equals the part area plus another part. So look at AR1 means area of the region 1. Area of the region 1. Pay attention to the region 1 means the curve is a positive number. So we can write it fx dx, x interval corresponding domain from -1 to 1. So -1 to 1. Look at another area. The area of R2, this part, pay attention to. How about? Okay, this is below the axis, means the definite integral is negative. So you can look from 1 to 2, 1 to 2, fx dx itself should be negative number, but the area must be positive. Negative minus means negative, negative becomes positive. So pay attention to the signs. If the minus is rated as plus, the question is wrong. So try to understand the geometrical meaning. Compute the first term, we can get the original function, the second, similar meaning. So the final result by itself, according to the polynomial's definite integral, equals 23/4. So the question is solved. Now look at the final question. Look at the question 2. Try to find the area A bounded by the curve y equals axis and x equals -2 and x equals 3. Sometimes you don't need to draw the figure. We can compute the corresponding area. The area of the region equals from A to B. Where is A? What is B from here? Okay, the given condition, x equals A, x equals B. Why? -2 less than 3. So it is our A, it is our B. Bracket, where is our fx? The curve. So from A to B, fx dx. Please pay attention to the geometrical meaning. Y equals this expression. The variable changeable between the interval corresponding fx is negative. The negative means corresponding the integral is minus. So we should write it minus. Why? Negative, negative become positive because the area of some region is always be positive. So you should write it minus. So go on. The question becomes very easier. Copy the term, copy the term. Sometimes you can write the -1 into this expression. -4 become positive 4. This term becomes minus x squared over 3 from A to B. It is our polynomial's integral, so you can get the final result 125/9. The question is solved. So now you can understand the question. If you write this, doesn't write this sign, you can get -145/9. It's wrong. Why? The area should be positive. So now the class is over. See you next time.